first, like little background. So operating systems in general, what are they? So essential in some of them. It's just a set of programs, just like the ones that you write, but they actually do all of the stuff that the ones you write are actually able to. So they're the backbone. They actually communicate with the hardware underneath. So it's just a collection of programs that somebody else has written because they were there first. And applications that we normally run, like web browsers, office suites, music players, whatever you use those underlying programs that manage all of this stuff for you so that you're able to, I don't know, do whatever you like. Some common OSs that you know, Mac OS 10, Windows 7, 8, they skipped the 9, 10, and GNU Linux. And yeah, so since this talk is about Unix, Linux, Mac is a Unix, and GNU Linux is obviously a Linux, and Windows is, well, Windows. So what is GNU Linux, though? Most people don't refer to Linux as GNU Linux. Well, the thing with Linux is that it's not an OS per se. GNU is the bigger part of what actually makes it an operating system. It stands for GNU is not, that's Unix. Right, okay. Disregard that, yeah, GNU is not Unix. It supplies a bunch of standard utilities that every operating system needs to be able to do what it does. So those things are like C compiler, your editors, the shell, so you can actually interface with the operating system, and just a bunch of other sysadmin stuff. A lot of the tools that I'm going to show you later for using Linux and Hills are actually supplied by GNU. And if you go into the help files, you'll see that they're all authored by the GNU project. So GNU is pretty great, and we need it. There's no replacement for them for Linux, as far as I know, but you could write it if you want. But GNU is part of like this free software movement thing where like maybe some of you have heard about open source and stuff like that. It's another topic entirely. It's about like freedom in the software and like just like anti-proprietary stuff and things like that. Maybe I'll talk about that more later. But these people who, well, it was started by Richard Stallman. He basically was not happy with the state of operating systems in 1984. He was an MIT student. And so he decided to write a Unix-like clone because Unix was the most popular OS at the time. That was completely free software, meaning like all the source code that you guys write, well, it's available. Anybody can look at it. Everybody can change it. Everybody can. There's no such a thing as piracy because everybody can share stuff. There's no like, I own this, you can't touch it. That's what proprietary stuff is all about. So these guys set off on the project to write a whole OS that was nothing but free software. So everybody can look at this stuff, change it, do whatever you want. It's up to you. There's no warranties or anything like that as a result. But Unix has always been and is still proprietary. Unix is more of a brand today. So it has a great legacy. But the GNU OS that they set out to do lacks a working kernel. Kernel is a very important piece of an OS, but it's just a piece. Well, enter Linux. Linux is that kernel. So basically, these guys have developed everything, and they decided to start working on the very last piece that you need to make a functioning OS at the very last minute. Well, at that point, they looked around. Oh, there's these people who are starting to do Linux. So they had the great idea of bundling the two together, and that's how we get GNU Linux. So Linux is an OS kernel. It's just a single but very important part of an OS. It manages the system resources. So a kernel is basically, that's the part that talks with the hardware. It handles all of the system processing, all of the communications, all of your memory management, making sure that every program has a turn on the CPU, that nothing is like being left out. It manages all of that. So as you can imagine, it's quite important. So yeah, it's not an OS, but a part of making one. We bundle it with the GNU utilities, and we have GNU Linux. And yeah, Unix is a brand. It's a trademark. To be a certified Unix, you have to pay a bunch of money to some certifying commission. They do whatever they have their ad hoc little policies. There's certification that you have to comply. So, I mean, these people don't care about it. There's Linux. There are some other OSs that are also like that. Linux is a Unix-like OS, meaning that it works like a Unix, but it's not technically Unix from these people's specifications of that. And yeah. Any questions on that part? Sure. So shells. What's a shell? Maybe you've heard of it already, but shell is the interface that you're going to use to control the computer. It is a program. Yeah, well, there's many different ones, but shell is a program that basically makes it so that you can communicate with your computer easily, and you don't have to know all the crazy stuff that goes on underneath to make all of this actually work together. Because, oh man, there's a lot of complicated stuff in computers. I'm taking assembly language this semester, and yeah, starting to see more of that. So yeah, there's a lot that goes underneath. But shell is an interface for that. And there's many different shells. Bash is the one that we use by default when we log into Hills, for example. And like, if you install any Linux, yeah, that's going to be your default shell, Bash. But there's other one. There's C shell, which was like a shell, which is like a C language. There's one called just shell. That's the original one that Bash improves on. And Z shell, that's today like what all the tweakers and not those tweakers, but like people that want to tweak their system and like do all kinds of things with it. Like they use Z shell. Bash is a little bit more limited. There's a bunch more. So we use the shell by giving it commands in a language that it understands. Well, we use Bash by using Bash scripting language. And it will take our input and give us an output. It's like a function, you could think of it. And we'll use Bash because it's the standard. It's similar to what Z shell uses as for its syntax. So if you know Bash, it's not going to hurt you if you want to be using some advanced stuff. Yeah. Well, I mentioned this word Linux distribution, and it's just a collection of pre-installed programs. So some people get together and they're like, okay, well, these are the set of default programs I want to use. So they make a Linux distribution where they take the Linux kernel, all of the GNU core utilities, and those things are like old command lines, so they're not pretty. Well, you go and you get Ubuntu Linux where they have already pre-configured everything. It looks pretty, it works nice, you don't have to think about anything like that. So those are your Linux distros, and there's a ton of them. I mean, you could all make some of them. I'm pretty sure there's a website called, what is it, Make You a Linux or whatever. So you can actually go and they teach you what goes into assembling a distro, what components you need, how to make them all work together. That's an interesting project if you want to learn more about that. So and stuff. So terminal is another thing. That's the program that hosts your shell. So terminal contains the shell, but it can also be used to, I don't know, control many other shells. So it is your container for using this shell program. So terminals are great. You are using a bunch of them in your Mac OS or something like that, as you see in Mac, which it's just called terminal in Linux. Whatever. There's many different ones. It's just another program, and it emulates some other really old stuff. But today we use it for running the shell and all the great stuff that comes with that. So let's get into the file system layout of Linux systems. So everything is organized in a hierarchy. It all starts at the top with a thing we call root. Yeah, and all the folders, per se, from Windows speak, they're all actually called directories in Linux. So the uppermost directory, well, that's your root folder. It's just signified by the little slash. So /, you say it as root, but it's not root. There's another directory called /root where the root user lives. And the root user is the sysadmin account. So like it has access to everything on the system. It's able to modify all the files, execute all the programs. It's the one that actually manages everything. So it's called /root. But all of the files, as you can see on the little picture, they start at the root. So even, yeah, so top directory, yeah, they contain all the files. So the leftmost branch, it goes home. Well, home is where all of the user home directories are located. So when you log into Hills, it uses, I think they renamed it as students or something like that for the students' home folders, directories. So yeah, so it's like a tree structure. If you've taken more advanced CS classes, you know how to make this in your favorite programming language.
Yes, I have a question with your file system layout. Are we talking on a single disk, single partition?
Oh, so on Linux, you can actually mount things.
Exactly.
Yeah, indirect. So you can have, I don't know, when you're launching your OS, you can mount different partitions in different places in the file system. It's very modular. And you can also change where you like consider your root directory to another place by using command. So it's like very modular. You can, there's probably a program for that, but you can make one of the directories be like a server. So it seems as if it's part of your machine. Like you go and log in into like some directory called server, but it's not actually on your machine that you're on the server. It seems like the interface is so nice that when you go and move into that directory to look at some files or whatever you do, it will actually be contacting the server and seeing what's going on in there. So it's very modular. You can connect pieces, put away pieces. Like, I think it's pretty great in that regard. Let's see. Yeah, and your home directory is where all of your stuff is going to be residing. As a user of the Linux system, you don't generally have permissions to go and modify a bunch of files because that would be a huge security risk. So the root account is normally dedicated to that, so that you would go log into the root account, and hopefully it's the right person logging in. So Sam Bound earlier today, he was talking about how you can hack into his server and yeah, you'll get user permissions. Well, that means you can modify some stuff, but not a lot. And by privilege escalation, if you can, I don't know what they do to hack into this stuff, but like you can get access to this root account. Now you have access to everything. You can just delete the whole server or anything like that.
Goats everywhere.
Sorry?
Pictures of goats everywhere.
Sure. Goats. Yeah, but Heels has a little bit of a different structure from a standard Linux, because I mean it's a working system. That's what they're actually using to manage, like, I don't know, thousands of students every semester. So they shipped it to whatever it is. This is just like there's a standard specifications for what a Unix/Linux file system looks like. Nobody has to follow it. It's up to you. It's like your own OS. So like rename folders, shift stuff around, and that's what most companies that use Linux and anything else do. So now a little concept that's really important for understanding like commands when we're using them. How we actually refer to files. So there's absolute and relative paths. So whenever you're using a shell, you are implicitly located in a specific directory at all times. When you log into Hills, you're placed into your home directory that I talked to you about. That home directory is, we use a little tilde sign to signify that, but essentially it's a shortcut to like start at the root, then go to home or something like that, then go to your username, and that is your home directory. But instead of you typing that out every time, we use this little tilde shortcut. And when you write programs, you no longer have to like know the username, because whoever is executing this little script, the home folder will always direct to their home folder, and you don't have to like pre-code or somehow fetch this information indirectly. Yeah, so it's home folders. Yeah, so I mean, a lot of commands that we'll be using, like you want to copy a file, you have to specify what file it is. And I mean, this whole thing is about specifying what files these are and how to use them. So commands like mv, which stands for move a file, and cpu, which stands for copy a file, they need to know what file you're referring to. Move, for example, takes two files. I mean, they both actually take two arguments. One is like what file you're moving or copying, and the other one is where are you copying and moving it to. So two ways to refer to these files. Absolute path. Well, absolute is when you start from the root, from that very upwards directory, like the little slash, and then you specify exactly where it is. You go, I don't know, slash, home, Alex, pictures, whatever file. Sure, okay, that's absolute. Well, but there is a relative path, and this is more of like just making our lives easier. It's a file location relative to where you are in the system. Once again, when you log in into a Linux system, it places you somewhere. By default, places you into a home folder. You can move away from it. You can go like two directories into your, like, I don't know, go change your directory to the pictures, and then go into like, I don't know, holiday pictures from summer 2015, and then, oh, I want to access that file. Well, you don't have to type it out from the root. You can go and actually use direct path, meaning like you are already in some directory, so you just specify where it is relative to where you are at that moment. So if I'm already in my home directory, and I know that right in this directory there's my pictures folder, I don't have to go home Alex, I'm already in home Alex. So I can just specify pictures / CCSF Coders, whatever. And this is the same thing as typing out home, so tilde/pictures, pizza coders. Sure. Okay, so these are your absolute and relative paths. So let's go and actually get some commands going for using Linux. So print working directory, pwd. So whenever you're actually working in a Linux system, so here is a, oh well, that logged me out. Hold on. Yeah, so whenever you are in a Linux system, right now, it placed me in home directory. If yeah, really hard to see. Let's see if I can do one of these. Yeah, so you can see that little tilde. So it means I'm in my home directory. I can type, okay. I can type pwd, and it says that I'm in my home directory. My last name is Golubev, so whatever. My first name A, letter N, Golubev. So in this case, they replaced my home directory, where all the home directories of users are located, with the name students. Doesn't matter. So print working directory just prints out wherever I am. So if I go ls, I get a bunch of files. ls stands for list files. So all the things colored in blue, those are my folders, and all the things are in white, those are my files, and the ones in like blue, light blue color, I think these are like some other type of files that Unix uses. So yeah, that's ls. I mean, ls is simple. ls just prints out the files. pwd just prints exactly where you are. So if I use the command called cd, cd stands for change directory, I can specify where I want to go. So once again, I'm already in my home folder. I don't have to go and type it out like this, like students, what is that, T, students, like this is very annoying to do. I can type it like this and go cd into students dev. Let's develop something. So there on the left in my command line prompt, it shows that I'm right now in home dev. If I run the pwd command once again, it prints out that I'm now in dev. Sure. So if I use cd without giving it any arguments, just by itself, it by default takes you to home folder. Home folder is pretty important, so a lot of commands just reference it. So that's cd, print working directory, so it tells you where you are. So once again, if I go pwd, now I'm back in my home directory. So let's go back to this. So that's pwd, print working directory. ls, list files, list all the files in your current directory where you're currently located. cd, you give it some location where you want to go. You use either an absolute path or use a relative path that we talked about earlier. mv, I mentioned this briefly earlier. This is a command where you provided first the file you're trying to move, and then the path to file where it's going to go. So let's see the use of that. So if we go here, we type mv, well, let's see. So let's go ls, go to a bunch of files. So I have some weird file called login.log. Not sure what that is. So if I want to rename it or move it to some other location, I use the move command. It just like I specify a file that I want. In this case, I'm using the relative path to login.log because it is contained in my current directory. And I specify a new name that it's going to be stored as. I could, for example, rename it as just login if I wanted. So now this file, this file is now named login. But that's like renaming, boring. So same thing, if I go and put it into folder git and login.log as its original name, it will now be gone from my home directory. And if I go and list files in my git directory, there it is. So move is pretty simple. Let's switch back. Right. And it's used for renaming files. There are no other command to actually rename files. Make directory stands for make directory. So it's going to create an empty directory in whatever location you specify. Not much to it. Just makes a directory. Yeah. A lot of these commands are quite simple because, I mean, you are using these to interact with your system. So really basic things have to be talked about because, I mean, right now it's just weird. So touch creates an empty file. So just an empty file, just like an empty directory, simple commands. And few non-essential commands. Date, that's going to print out a current date. So top queries active system processes. So it's going to show you what processes are actually running on the system. Good to know. Cat will take a file, and whatever is inside of it is going to print it out. Simple. All these commands are simple, but by chaining them together through a little mechanic in the Bash scripting language, you actually can get some advanced behavior. And if you take some of the scripting classes here at City College, you will learn a lot about managing Linux systems. For example, somebody today mentioned CS160. That class is split into A and B, and they're basically going to cover, like the A class covers a lot of the stuff that I'm talking about right now. And then in the B portion of the class, you really get into some more advanced, like manipulation of the file system and just messing around with stuff. And it's a pretty interesting class. So, what's up? We have 45 minutes.
Yeah, but you're talking
Sure.
supposed to take all 45 minutes now?
No, but I said it wasn't going to take minutes. Sure. I mean, okay, we got password, which is change your password. So some people may need this command on Hills. If you already know your password, though, because it's first going to prompt you for your old password, and then you replace it with the new one. Logout or exit. Forgot to bold that. Yeah, so two commands, just quit the running shell, log out of whatever you logged in. RM. Very careful with this one. Very careful. Linux doesn't ask questions. Like when you're working with the command line, be very careful about what you tell it. It assumes you're an advanced user, no matter how much time you've spent with it. So when you say RM a file, it's not gonna prompt for anything. It's gonna delete just exactly what you did, what you asked it to. No prompts or anything. You can make it ask the prompt, but you have to specify this, and we're gonna cover it in the next slide. And then we have less, a weird command that lets you actually browse the file, move around instead of cat, which just kind of prints it out, and you can't like, what was at the top of the file if the file was too big for the screen or something like that. Less actually lets you move around the file and stuff like that. Pretty useful. df shows available disk space. Not as useful on Hills because I think it tells you, oh, let's actually check it real quick. So if we go df, yeah, a bunch of stuff. These are all the different Hills directories, mounted partitions and stuff, whatever they are. Let's go back. So, but if you're running this as your own system, Linux, then it's a lot more useful because you're actually inquiring about your own hardware. So Nano, some of you who are taking intro Linux classes or whatever CS classes, you've probably seen Nano already. It's just a nice beginner's editor. I might do another talk I don't know, later in the semester about some more advanced text editors and how they're useful and how cool they are. But Nano gets you where you need to go really fast. No knowledge necessary, no prerequisites. So, and uname is a little command that allows you to see what the information about the OS. It prints out like what instruction set is it using, is it 64-bit, whatever, some little arbitrary info that it chooses to print out. But it might be interesting to see what are you actually using, since there are so many different varieties of Linux. So, command tags. In this uname command, I used this -a. It's separated by space from uname. So these are flags. These are actually configurations for different commands. So it's really hard to actually know. Like, I mean, if I just press ls, it prints out everything in the file. Well, what if I want to filter it or something like that? So in order to implement these configurations in the command line, since it's a boring text environment, we use these flags. So flags just specify some behavior that it's able to do, some additional stuff. Yeah, last A. So you can use it with the last command. If you pass it the A flag, it will actually print out everything, including something called dot files. Dot files are files, just like any one that we've seen before, but they start with a dot. Anything that starts as a dot is a dot file, and those are hidden from when you go ls normally, because they're configuration files. We don't want to see them all the time, so the system normally hides you from them. But if you want to be configuring your system, obviously you want to see what those files are and where they're located. So in those cases, you'll be using ls-a. And there's a lot of other flags. So You said 5 minutes.
You got 3 now.
3 now. Okay. Well, it is the last slide, so, well, one more. Yeah, so a lot of different flags. That's how you, I said tags on top, I just realized that. Okay, never mind, they're flags. So, and how can you get help when you're trying to learn a Linux system? This is a lot of stuff. I mean, I talked for a bit, yeah, I guess. But this is a lot of stuff to kind of take in when you've never seen a Linux system before. So, to get help, we use something called man. Man is the man with dealing with the stuff. Man is short for manual, so no little gender identity, whatever. So man is a program that takes as input another program's name. So for example, if I want to find out how can I use ls? Well, if I go man ls, this will show me the documentation for ls program, and I'll be able to see what different flags does it use, what do they do, how can I combine them together. It's the help file. So when you write your programs, they ask you to comment things in and stuff like that. Well, I guess somebody is appointed a role to actually take those comments later on and actually document how your program works, so that we who don't want to look through the source code to see how this thing works.
There are even like some of the newer languages people are like saying there's syntax to like write your comments that will all automatically get compiled. And,
Oh, interesting. So it's kind of like Python requiring white space and stuff like that. Interesting, yeah. I mean, comments are very useful, so comment your stuff, because in a week you will be like, what the hell was this? So if they're not good enough, because a lot of times they're quite terse, it's kind of hard to parse them. Google is the easiest thing, because there's so many people out there trying to learn Linux, because it's one of the hottest technologies today. Like, I mean, a lot of these startups, all of them are using Linux. I mean, Amazon Web Services, all these servers are Linux and stuff like that. Linux is open source, so, Linux is open source, so it's free. So companies are ready to adopt it. They don't want to be paying for stuff all the time. So Google for stuff, there's a ton of information. And then at the end of it, there's us. There's me, Gani, Alan probably as well know some Linux. Like a bunch of us at the Coders Club, we know a bunch of Linux because we have to deal with it all the time. And a lot of us like it. I mean, I run it as, this is not my computer, but I run it on my computer at home. So I enjoy how it works. I enjoy messing around with it, configuring stuff or whatever. So we are the best resource. So yeah.
We don't have a Linux users group right now. We used to have a Linux group.
We're gonna be started. Don't say no.
Yeah, we can start one if somebody wants to help lead that up, and that'd be great if somebody.
Wednesdays, 5 to 6.
Wednesday, 5 to 6.
Yeah.
Oh, we do have one.
There's now.
There's no. Yeah. I don't know. Some of you guys might not be old enough to remember what it's like before Macs and Windows. Everything was command line based. A lot of it's called DOS. A lot of Linux almost all Linux is really command line based with a pretty GUI on top of it.
I mean, that's like all computers are, though.
So if you remember that, yeah. So I guess there is a Linux group, users group. We'll try to get more information out on that. If you want to learn more about it, I think Alex is going to maybe have another talk for more advanced stuff later.
Yeah.
But
this is more of like just stuff you got to know. I mean, these are not very complicated topics, but I mean, to get to the high level, you got to get through the fundamentals. So,
Speaking of the fundamentals, they have these handouts at the ACRC downstairs on basic Linux commands. I just grabbed a handful if anyone wants one.
yeah. So if you're taking a class where intro to C++, they're going to teach you to
Stop it.
compile
Recording.
on hills.
Yeah.
A lot of the teachers